Inside a residential roof space, structural members are under constant physical stress. Gravity exerts a relentless downward pressure. The frame must support the dead load of the structure itself alongside the live loads of occupants and materials. Simultaneously, wind creates lateral and upward uplift vectors that attempt to displace walls and separate the roof from the building. AS 1684.2 acts as the technical manual for resisting these forces, providing the specific member sizes and connection details needed to maintain structural integrity. This high-angle view of an exposed timber roof shows the complexity of the modern residential frame. Every intersecting member must function as part of a unified load-bearing system. Competent supervision of this code requires the site team to treat these framing requirements as applied structural engineering. Beyond the physical requirements, the site supervisor and the license holder carry the legal liability for the frame's performance. This flowchart illustrates the legal pathway from the National Construction Code to the job site. By satisfying the H1P1 performance requirement through the H1D6 4C call-up clause, the builder achieves full NCC compliance. This creates a legal shield, removing the need for additional engineering justification. This protection is limited to Class 1A and 10 structures. It applies only to buildings up to 2 stories high with a maximum width of 16 meters and a roof pitch not exceeding 35 degrees. Any unverified material substitution on site invalidates this compliance shield. Without a documented engineering recheck, legal liability for a failure returns to the license holder. The site's wind classification determines the parameters for every structural calculation that follows. This chart defines the categories. N1 and N2 classifications cover most inner suburban locations and utilize a standard set of span tables. Locations categorized as N3 or N4, typically coastal or exposed sites, require entirely separate supplements with larger member sizes to resist higher gusts. Using an N2 span table for an N3 site means every member, connection, and bearing in the frame is technically non-compliant. These environmental factors dictate the required dimensions of the timber. The code identifies these by depth followed by breadth, for example, a standard 90 by 35 millimeter stud. This chart outlines timber classifications. F grades, centered, use visual inspection for knots and grain, typical for WA hardwoods. The left column shows machine-graded pine, like MGP-10 and MGP-12. Though identical in appearance, they are not interchangeable. Each requires specific span table entries. Engineered wood products, including LVL and I-joists, require supervisors to follow specific manufacturer span tables and lateral restraint instructions rather than general code tables. Substituting a lower timber grade without recalculating the span requirements is a direct breach of the building's compliance pathway. Field inspections often reveal specific areas where framing fails to meet these technical requirements. The ceiling opening trimmer is a common site of noncompliance. Here, the builder omitted mandatory framing brackets, and the trimmer lacks sufficient breadth. Clause 7.2.4.4 provides the specific requirements for openings that exceed 1 meter. For every 300 millimeters an opening extends past 1 meter, the trimmer breadth must increase by 20%. Framing brackets, like multi-grips, also become mandatory. Another critical failure point in roof load distribution involves the valley rafter. This valley rafter lacks necessary bidirectional support. It is supported by an underpurlin in only one direction, failing to meet the code's load-sharing requirements. Clause 7.2.13 mandates that valley rafters be supported in both directions unless alternative strutting points are available. Omitting a single secondary support or bracket shifts unintended loads onto other members, which can lead to systemic structural failure. On the exterior, eaves require specific construction techniques to manage overhang loads and frame movement. This diagram illustrates standard boxed eaves construction. Structural fascias are used here to distribute forces acting on the overhang. Note the 12 millimeter clearance requirement between the soffit bearer and masonry wall. This allowance is mandatory to accommodate frame shrinkage without damaging the exterior. This overhead view shows a correctly framed eave system where clearances and structural fascias have been properly implemented. It is important to distinguish between general wall bracing and truss bracing. Bracing for trussed roofs is governed by AS 4440, and these two standards should never be cross-applied. Vertical uplift forces are managed through a continuous tie-down chain. This tie-down chain creates a direct load path from roof batten to the footing. For every joint, the supervisor must determine if nominal or specific fixings are required. Specific fixings require calculating the actual uplift force, then selecting a fastener meeting that kilonewton requirement. If a single connection in this vertical chain is omitted or undersized, the roof's resistance to wind suction is compromised. AS 1684.2 governs the vast majority of Class 1 timber-framed construction in Western Australia. This standard provides the mathematical framework necessary to ensure a residential building can resist environmental loads. Structural compliance is a matter of precise calculation rather than builder intuition. Every shall clause in this code is a mandatory legal requirement. Ignorance of these clauses is not a valid defense in a building tribunal or court. Supervisors can proactively manage these risks by using existing inspection data to improve on-site outcomes. Reviewing certifier inspection reports and cross-referencing defects back to their specific clauses helps identify and correct common failure points. Use your site walks to explicitly verify at least one specific clause against the standard. AS 1684.2 provides the technical roadmap for building frames that resist physical forces and maintain the builder's legal compliance.